Okay, this is lesson 25. We're only going to do the first half of it. So this is all Trigonometric Functions Part 2. We're taking section 5.2, and we've actually broken this one up. This is the second half of it. And we're going to continue on with trigonometric functions. So we've talked about using the reciprocals. Here I labeled, if you look at the textbook or if you look on your homework, these problems would be in conjunction with the group of problems that are 5.277 through 86. Okay, so it kind of helps to see what those are all about. Okay, we want to find the sine theta given that cosecant is a negative 12 over 2. So in the past, we were given a value and we had to come up with the 6 trigonometric functions. Here we know one of them. We know cosecant. Okay, but we want to find its reciprocal sine. So what would we do to find sine from that cosecant? What would we do there? Travis? Well, if cosecant is a negative square root 12 over 2, right, you're going to apply the reciprocal. So basically you're going to flip that, right? And so that makes it, without having to rationalize it yet, that would make it negative what?
2 over the square root of 12.
That's right, 2 over the square root of 12. So let's look at this for a minute. Oh, that's right. Keep forgetting. Let's back up here. All right. If we look at this in terms of 1 divided by 12 over 2, and you apply the reciprocal to that, so in other words, if we have remember this, A over B equals to A divided by B equals to A times the reciprocal of B. Remember that? Well, this would be like the B. So this would be like saying 1 over the square root of a negative 12 would be 1 divided by negative square root 12 over 2. And so that would be 1 times a negative 2 over the square root of 12. Okay, so basically all you're doing is you're taking that denominator and you're flipping it. Okay. Now we have to rationalize that, but we can simplify the square root of 12 because the square root of 12, factors of the square root of 12 is 4 times 3, right? So this would be like saying here, square root of, let me use a thinner, square root of 4 times the square root of 3, right? And so that's where you get that 2 square root 3 from the square root of 12. And then from here, the 2's can cancel. And so that's where we get the negative 1/3. But we have to rationalize that. It's not simplified, leaving that radical in the denominator. We got to rationalize it. Okay? And so we have to multiply that square root of 3 over square root of 3. And so that gives us here, negative square root 3 over the square root of 9, and that's where we get negative square root 3 over 3. All right, questions with that? Okay, here we have our 4 quadrants. Quadrant 1, Quadrant 2, Quadrant 3, Quadrant 4. We have our x values are positive, our y values are positive in Quadrant 1. Well, that means that x is greater than 0. If x is greater than 0, it's positive. Y is greater than 0, that's positive. R, think of R as synonymous with the hypotenuse. R is always positive. Just like the hypotenuse is always positive. R is always positive. Quadrant 2, here we have the x values are negative, y values are positive. So x is going to be less than 0 because it's negative. Y is going to be greater than 0, so it's positive. Okay, so sine, since sine is synonymous with y, sine is positive. Well, if sine's positive, its reciprocal, cosecant, is also positive. Here we have, in Quadrant 3, x values are negative, y values are negative. So x is less than 0 because it's negative, y is less than 0, that's negative. So tangent, why is tangent positive? Well, let's look at this. Oh, darn it, I keep forgetting that. Why is that? Well, if we have tangent, remember, is sine over cosine. So if sine is negative, right, and cosine is negative, well, negative over negative gives you a positive. And so that's why tangent is positive in Quadrant 3. So you got to watch it with tangent because you're going to be given values that are positive, and you're going to look at coming up with the 6 trigonometric functions, and you're going to think, where did those negatives come from? But you have to think in terms of tangent is positive, but its sine and cosine values, they're going to be negative. So you have to watch that because you're going to see like these hidden negatives in those values for tangent. Okay. And then we have our angles 90, 180, 270, 360. So when you're looking at these angles, you want to think in terms of 90, 180, 270, 360. To determine, you want to know what quadrant are we operating out of. So you look at these 4 angles here to determine, where are you at on the coordinate plane in the unit circle. All right, for example, 87 degrees. Determine the sines of the trigonometric functions and angle in the standard position. So 87 degrees, what quadrant would that be in? What's that? Quadrant 1. So sine and cosine would both be positive, right? Well, how about 300? Quadrant 4, that's right. Let's take a look at that. Here's 90, 180, 270. Well, 300 is going to be over here between 270 and 360, right? So this is 300. And so that would make x positive, y negative. So cosine's positive, sine is negative. Okay? Questions with that? How about secant and cosecant? So here we have sine, cosine, tangent. We said that sine is negative, cosine is positive. Well, what about tangent? What's that going to be? Negative, that's right. Because if you look at it in terms of sine over cosine, right, that's going to be negative over positive. All right, good. So how about cosecant? What's that? Positive or negative? Negative. If sine's negative, cosecant is also going to be negative. Secant. What's that? Positive. All you got to do is look at its reciprocal, cosine. Cosine's positive, its reciprocal is going to be positive. And cotangent, what's that going to be? Negative. All we got to do is look at tangent, right? So the reciprocals are going to be the same signs. They may be flipped, right? Or they may be the reciprocal, but the signs are going to be the same. Okay? Questions with that? All right. Determine the signs of the trigonometric functions of the angle in standard position with the given measure, negative 200. So I'll help you get started with that. Where, instead of going 90, 180, 270, 360, where is negative 90? Let's look at that and then go that way. Is it going to be where 90 is, or where 270 or 180? Negative 90, where's that? Is it positive x, positive y, negative x, negative y? Axes. Negative y, right. Negative 90, right? So I got you started. All right. Now figure out what negative 180, negative 270, negative 360, and then determine where is negative 200 in that coordinate plane. Good. That's right, the second quadrant. Negative 180 and positive 180 are in the same place. Negative 270, that's where the same thing as positive 90 is at. So we're going to keep going on around, go past 180, but not past 270. And that's negative 200. Okay, so we have to determine, we're just looking at signs, positive and negative signs. Determine what are the signs in quadrant 2, and from there you can come up with sine and cosine and then their reciprocals. Sine, cosine, tangent. All right, so go ahead and try that. Okay, first of all, what are the signs going to be for x and y? Sydney? Negative for x, positive for y. So that means what is cosine? What is sine? What is cosine? Positive or negative? Good. Sine is always synonymous with y. Cosine is always synonymous with x. So sine is going to be positive. Cosine is going to be negative. And so their reciprocals, which would be what? Positive and negative. Well, reciprocal identity for sine is what? Cosecant. Cosecant. Good. And so, Travis, what's the reciprocal for cosine identity? Secant. Good. And that's negative. All right, good. And tangent? Harley? Negative. Good. You always want to think in terms of sine. Tangent is sine over cosine, right? So that would be like saying plus over a minus. So that's negative. And how about its reciprocal cotangent? Negative also. That's like saying negative over positive, right? All right, good. Questions with that? Okay, identify the quadrant or possible quadrants of any and angle theta. Sine theta is positive, tangent is negative. Okay, so let's look at that. Sine is positive, tangent is negative. Our sine theta is greater than 0. Tangent theta is less than 0. So that means sine's going to be positive. Tangent's going to be what? Positive or negative? If it's less than 0. Negative. All right. Well, sine, remember now, sine is like y. Sine must be positive in what two quadrants? Travis? 1 and 2. Good. Because sine's like y, right? Y is positive in 1 and 2. Sine is positive in 1 and 2. Tangent is negative. So sine is positive in 1 and 2. Tangent is negative in what two quadrants? 2 and 4, right? Because this would be negative for cosine and sine. Sine and cosine and sine, right? So tangent's negative in 2 and 4. So you want to look at the intersection. What's common between these, both of these? 2, right. So our answer here is quadrant 2. Okay? And the reason why we have these is because you may be given a value like sine theta is equal to, let's say, -3, and tangent is greater than 0. So this tells you sine is negative, right? This would be like saying sine is less than 0. Sine theta is less than 0, right? Because it's negative. Tangent's positive. So from here, you have to determine what quadrant you're in. Well, sine like y is negative, so that would put what two quadrants are sine negative? Well, where's y negative? Harley? 3. Anywhere else? And 4, right. Tangent is positive. And what two quadrants? Sydney? 1 and 2. Remember now, this is negative and negative. So that's sine over cosine, right? So that would be like negative over negative is what? Positive, right. So that would be 1 and 3, right. So therefore, we've got to be operating out of quadrant 3. Okay, so we would look at that, quadrant 3. Okay, opposite over hypotenuse. Well, I can't do that. But hypotenuse can't be smaller. But anyways, you guys get the idea from there as far as what quadrant. Okay? All right. Cosine is less than 0. Secant is less than 0. Okay, so now we have cosine theta is less than 0, and secant is also less than 0. Determine what quadrant we're operating out of. They kind of threw. That's interesting. They would put that in there. This one may actually be more than one. Okay, Dylan, where would cosine be negative? 2 and 3, right. Cosine's like x. So that'd be quadrants 2 and 3. Secant, how about that? Also 2 and 3, right, because it's the same. Secant is the reciprocal of cosine, so it's the same. So the answer here would be quadrants 2 or 3. We don't know because it could be either one. Okay, good. All right, questions with that? So we're going to leave it at here for now, and we're going to go ahead and I'll pick this up again next time.